And we are getting started, guys. The first run ever is here. We trained last night. So the run was running roughly 10 hours on 2 of my RTX 3090. Basically, I was training on English to Turkish and English to Hindi just to catch any potential issues. And today we're going to basically analyze all of the plots. We're going to understand how each of them are being measured and logged, and a ton of more details. We're going to try and do some predictions, do some translations, actual translations between English and Turkish, English and Hindi. I'm going to ping some people who are in our Lang Champions doc. So there is a ton of cool stuff that we're going to be doing until late night today. And then I'm going to kick off yet another run with the learnings that we gathered during the day today. So this is going to be probably one of the most exciting days for this project, and I'm really hyped up. So let me first share the link to the stream with my people in the server. So here we are. Oops, NLLB. Where is my open NLLB? Okay. Let's go. So let me see what to-dos I have. There is a ton of things that I have to do now. Basically, for now, we can focus on doing this set of to-dos here. So this was the first run, 615 million, 2 directions only, 36 million and 3 million sentences here. And then I've done some temperature sampling so that we upsample Hindi and we downsample Turkish a bit. Let's see what we can do. So we've done this. So we want to test a checkpoint on Turkish and Hindi. We want to evaluate them on Flores 200 and also qualitatively. So it's going to be the first task, I think. And then in the validation, what do we... Then we have to do some... I have to do some analysis of the code base later to understand why are we doing some things. Like we are, for some reason, we are doing validation on 3 subsets. One is valid, which I don't know what it means exactly, and then the 2 ones are just directly on Turkish and directly on Hindi, which makes sense. Then I want to understand whether I can somehow do parameter sharding as opposed to data parallelism. And then, so we can basically, this is kind of related. As we have an issue, we can go above 3000 without hitting OOMs. So that's one thing additional. Then when DB, I want to understand what do we log exactly and understand all of the plots. So all of these are related. And then we potentially want to add sacred blue and sampling text during the actual training so that we have that logged somewhere as an artifact inside of weights and biases. So as I said, a ton of things. And then there is also this IA presentation, which is just Cohere's effort in collecting various monolingual. Hey Lalit, welcome man. I haven't seen you in a while. So yeah, they are basically focusing on collecting monolingual data for various languages. Okay, so let's start from the start. I think this might be the first task. Then we can do this. Then we can do all of this, and then at the end we can do this. This is going to be the plan for today, I think. This is like different tasks we have to do for today. Okay, let's start with the testing the checkpoint and evaluating on Flores and qualitatively. Let's see what we can do. By the way, here are the curves. Here is the validation loss. there were no spikes. We went all the way down here. And then we have the train loss, train inner, NLL loss. Here's the learning rate. Let me find where is my train loss. The train loss is here. There's some overfitting going on, obviously, and I trained on multiple epochs. I'm not sure what's the recommendation for machine translation. We're gonna figure out those details and hyperparameters along the way by just testing, playing, reading the literature. So I don't think that's gonna be the super hard part. But this is the report. And by the way, it's available in our Discord channel, so you can open the URL there and play with it yourself. Good morning, SQ. Not a few models. This was the first one, actually. This was the first one, and I selected deliberately these two directions because they are the highest resource directions in our training data set. So that's why I picked. That's why I picked this. Okay. Good morning, SQ again. Let's try and now load. Let's try and now load these checkpoints, and then we can do some. Then we can do some evaluations. So let's see how we can do that. I do have some inference config here from before. Let me find it. There is a train sweep, train fine tune. There is the generate. There is the interactive. I think we might want to do interactive for what we're trying to accomplish. So yes, I'm fairly sure. Yeah, this was the one. I actually played with this already. So I think we can just reuse the interactive config. I'm not sure what this dummy path is. I know we have to pass it in because otherwise there are some issues. Let's see. So all in all, we have to go to versec CLI and go to the interactive script. But let me just quickly walk through this. So the input for us is going to be actually Flores. So let's go and open up versec. And let's find under examples, under NLLB, under modeling, actually under data, under eval data sets, under dev. Let's see the actual qualitative translations here. So let's first do Turkish. Let's grab copy path to this one, copy the path. So input is gonna be English here. Okay, so this one. And then we want to use what? We want to use, let me grab the SPM models we have, which are again in versec dictionary, copy the path. Let's just modify this. Here we are, modifying that one. And then the path to checkpoint, I guess we want to use the best one, but I'm not sure because we have two shards here. I'm not sure how these are gonna be combined. Can I just grab any one of these? I'm not sure, but let's try. Let's go with the best one, best 0, copy path. Okay, let's use that one. And then languages. Okay, languages we can keep those. And then we want to do English, Turkish. Okay. So this is going to be Turkish as well. Beam 5, sentence piece. All of that looks good. Then there is the model, copy the path. Okay, FP16. Let's go sentence by sentence. So now all of this looks good to me. Add data source, The only thing I'm not sure about is this dummy path. What is it exactly? We're gonna see in a couple of minutes. Encoder length token, decoder length token. Do we have to specify those in the interactive? I'm not sure. And we did specify them actually. So, okay, let's try and run this. So fair-sec CLI, interactive, here we are. Let's set the config to interactive, and let's see whether this thing works out of the box, whether I might have messed up something. For example, there is a ton of unknowns, like this, the sharded checkpoints. Do we have to pass both of them or whatnot? I expect they're just duplicates. But then why would we save both of them like that? I'm not sure. We're gonna check out. Okay, so get the interactive parser, parse, and we get the arguments. Where is this dummy path saved? Let me see. Dummy path, plasma. Do you see it anywhere? Because I don't. I have a ton of airplanes flying above me. Maybe we have some military exercise going on here in Serbia, which is annoying. Let me see. Okay, I don't see it. Let's quickly enter here. User directory. Okay, the first one might be just user directory. Let's just continue. F5. Let's go. Some asserts. Log in the config. Setting the seeds. Using CUDA. Yes. Set up the task. Okay, load the model ensemble. Why is this load model ensemble? The path I passed the 1 to shard 0. We have the task. Okay, let's see what happens if we enter here. Hit F5. Let's go here. Hit F5. Okay, they do expect just a single file name. Okay, and then we go through the file names. Assert that the number of shards is bigger than 0. Yes, it is. Get maybe sharded checkpoint file name. Let's see. No, they messed it up. They added another shard. Okay, maybe we just have to pass in the best and then they'll take care of it. Part 0. No. Okay, best shard 0. Let's go. We load the state. To the CPU. We grab the local path. Loads the checkpoint to CPU. If doing single GPU training, or if the checkpoint is only being loaded by at most one process on each node. Load on all ranks should be false. If all processes on each node might be loading, should be set to true to avoid the IO conflicts. Okay, let's see what will happen. Replication counts. 1. Get path to load. If there's multiple paths, then we go there. Otherwise, we just load here. We might want to actually go this direction because we do have flat FSDP shards. This is probably what we need, but let's see for now. Just load this. Will this fail? It will not. Okay. Done reading from the disk. Okay, we can just exit. Build the model from the checkpoint. Will this work? Apparently it worked. Something happened. Will this work? Apparently it did work. And then state shard index 0. And that's it. So that's the ensemble of multiple models. So here we have just a single one. 4 models. We have it. We put it to the GPU. So let's see what happened with my... Okay, we loaded the one on the shard 0. On the GPU 0. Prepare for inference. Build the generator. Build a tokenizer, build a BPE. Let's go. Load some dictionary, resolve max positions. This would be 512. Yes. Let's go. We are now reading one sentence at a time. On Monday, scientists from the Stanford School of Medicine, blah, blah, blah. And then we go... we batch, we grab the inputs, task, max positions in code function, okay. We get the batch. The batch contains the source lengths, the tokens and whatnot. Let's just see if we do batch keys. What's the type of this object? It's a type of batch. Fair enough. Then let's just do batch and like dictionary. Let's see what this one has. Okay, let's just see what we have. Batch size 1, tokens, lengths, constraints. There are no constraints. We move them to CUDA. We built the sample. And then we do the inference step. translate time, total translate time. And then we go through the hypothesis and we append the results with the tokens and then some additional processing going on there. Okay. So far so good. Nothing failed, even though I'm still suspicious that this loading of shard 0 without shard 1 worked. Maybe. I would expect they're just like the same files. Like, let's quickly check that, guys. Let's just do the following. Check whether two binary files are identical on Ubuntu. We can just do a diff. So if we go to here, model checkpoints, first run, let's just open the containing folder. Let's actually, let me open up a new window here. Let's navigate here. Okay, and let's just do diff between what? Between the best shard and the second one. Okay. Diff binary files differ. Okay, they are different. At least, if nothing else, they might be different in... Oh, wait. Okay, this second one is probably just some dummy data parallel thingy, because the first one is 4.7 gigabytes, the second one is 37.4 kilobytes. So apparently the shard 0 is the main one. Okay, let's see. This was a good check. It's good that we've done this. Aha, thanks SQ. Let me try for the batch. Clear batch. Let's see this. Nice. Okay. Yeah, but we don't see any. Let's just do string of batch to grab all of these fields. And yes, we get them. Okay, so we have the constraints, we have the count, IDs, index, source length, and source tokens. Thanks, man. Super appreciated. Okay, let's enter here. Inference, so we just enter the no grad context. We grab this. If not, get decoder language token for Turkish. And then grab the source tokens, the batch size. So what we do is we expand source tokens to add, we prepend, I guess, or we append why target? Wait, shouldn't this be source? Let's quickly see. So we have expand batch size 1, 1, nothing will happen here. So we just do this. And then expand and then 2. So let's see how this is added. 256184. Okay, this is just for the, okay, these are the prefix token for generation. Got it. Let's go. Let's call the generate. Prefix token, no constraints. Sample and models. Let's go. Generate. We are in the sequence generator. Some annotation. of the model sizes. Okay, net input. Grab the source tokens, grab the source lengths. Beam size is gonna be 5, I guess, yes. Constraints, initialize constraints. Nothing. Max length 200, because we have what source length is already 58, and this is set to 200. Okay, did we set that in the actual launch? Did we set the maximal generation size? We did not. Okay, so that's probably just a default setting. Let's see. Forward encoder. Okay, we get some outputs. Encoder outputs. We initialize with zeros. We fill with padding. Long padding. What does... Okay, it's too smart enough to know... Does this just fetch the device of this underlying tensor? I guess it does. Let's just see where we can enter here. No, we cannot. This is just compiled. Beam size, length, okay. Let's go. Finalized, finished, blah, blah, blah. We can just keep on going here. Let's go. And then we step for the... And we have, okay, so here is the forward through the decoder. We grab the tokens. We are now at the step 0, which means until 1, we fetch those tokens. We pass them in together with encoder and incremental states and temperature. Let's see whether we get anything. Okay. Candidates, finalized. To matches both device and the D type of the tensor into. Awesome. Thanks, man. Did you search that on PyTorch doc or you just know your PyTorch? Okay. Finalized. Okay, we get something. Let's exit. Translate time. We go here and we append stuff. Let's go. Post-process the predictions. Decode. Print. Okay, this looks like Turkish, guys. Looks like Turkish. Not perfect Turkish. Far from perfect Turkish, but let's see. Okay, we got something. No, this definitely doesn't look super good. I guess this was a sentence, right? You can roughly see some some glimpses of this looking like Turkish. Why is this output so confusing, guys? Why do we get first tokenized output and then colon. Why don't we just get D0? Why do we? Just a second, let me see what's the output format here. D and then score. Score followed by the actual. Okay, so this is the hypothesis. Oh my god, what is this? What is this? Let's just find somebody who speaks Turkish. Well, listen, today we're just trying to nice. Today we're just trying to get things to work end to end, to understand what's going on, how to load these checkpoints after training, all of that. So it doesn't really matter if this is not completely good translation. I literally trained it for 10 hours, kicking off the first hyperparams I had there. Like, so who knows? Let's see. Turkish, anyone? Nice. I have one person. That's cool. Actually, Bilgehan was very active in the Discord in the early days, so to speak. Let me... we don't train on Turkish to English. We just trained on English to Turkish. But you're right. You're right in the sense it's gonna be easier for us to eval stuff. We can kick off the next run. I just have to see whether we have the same amount of text. We can always, of course, swap the directions, but you're completely right. That's what we're gonna do, and then we can compare ourselves. Great suggestion. We're gonna to-dos for the next run. I'm also just trying to engage people, so this is kind of part of that strategy for people to feel like they're contributing. Okay. Let's kick it off. I've hit F5. So we're just getting some translations. The good thing, guys, is it's working. It's not crashing. We took a checkpoint and we tested it. We should probably make this output a bit more clear, like English sentence and then a sentence and then Turkish, as opposed to having to parse through this wall of text. Or just output it somewhere. There is a lot of these AMP symbols. Okay, let me see whether it makes sense to, whoops, to wait here. Where do we stand with the number of processed sentences? Do we have any? Okay, this will actually, we can just stop it because it keeps on running here and then just does the logger info and then it's done. And that's the main function. Okay, let me see what's the memory consumption. What's the memory consumption during inference? Okay, this is much better than doing training. Obviously, there is no optimizer states and stuff, so like only around 7 gigabytes. That includes OBS streaming and stuff, so maybe the whole thing is around 5 gigabytes. So you can run this on your system as well. Okay, I'm gonna stop this now. Let's quickly go and understand why do we have let's first analyze the Hindi. Let's try and do the Hindi now. Hindi will probably be worse. So English Latin to Hindi Deva, and then again we keep English. This remains the same, this remains the same, this same. This is not the same, we need to swap this. And also here. Okay. All of the rest is the same. Okay. So let's go. Let's rerun for Hindi. There's CLI, interactive. Run this. Print. Let's go here. Hit run. Okay, F5. Run. Loading the model. Okay. Oh, okay, this doesn't even look like Hindi completely. This is messed up. Oh, actually, it looks better here. Let's see. Let's just go to Google Translate as well. Let's try Google Translate. Let's go from Hindi to English. A new waste of life tool that could be manufactured in a way that cells can't. A tiny volatile register that's standard for every US printing can be used. Guys, this is actually not completely messed up, but as long as Google can roughly estimate what happened, it's not University of Boroughs waste of life tool. Wait, we have to take a screenshot of this translation. This is just miraculous. This made my day, guys. Okay. I have to share this on Twitter, guys. This is just... Let me just highlight this waste of life. That's the best part. The waste of life is just... what can one use, guys? What can one use to just edit? Like, I just wanna make a boundary around waste of life, like a red box or something. I usually use Paint in Windows. What's the equivalent of Paint here? Or copy the image. Let's see. Ubuntu. Ubuntu equivalent of Paint. No clue, I'm also a Paint kind of guy. X Paint. M Paint. Okay, there is a snap. There is actually a... It's an open source repo apparently. Really licensed and cross-platform. MIT. August 23rd. Guys, we need the memes. We need the memes to stay healthy and happy. So let me, for the sake, and it's because it's also just a nice milestone of the project. We actually have a translation in Hindi, in Turkish as well. And that's super cool. Okay, let's go here. Image cannot be pasted. The clipboard does not contain an image. Nice. Nice, I see what I have to go and figure out how to download this in Discord. Why does everything have to be so complicated? How does one... You can delete it, but you cannot... I can take a snapshot of the snapshot. That's gonna be the recursive nature of... This is just like Inception. Let's go. Okay, just capture this one. And now let's open Pinta. Image larger than canvas. Expand the canvas, of course. And then we want to edit. How does one add a simple box in Pinta? I'm a simple guy. I just want a simple rectangle. I want to make it I want to change its color to red. Okay, I think we're making a progress. No, go back. Go back. We need thicker width. Let's go to 5. More. We need more. Okay. That looks good. Why do we have all of these weird... I have no idea what's going on. Okay, this looks good, guys. Let's now just try and save this. Save as. Let's go to downloads and just in the translation run 1. We should probably make a directory here somehow. Can you just create a new directory on the fly? Okay, I can. Open NLLB snapshots. And here, let's save this as a in the translation run 1. Quality looking good. Making progress. We learned how to use a new tool on the job. Wasn't that great? Okay, so Hindi translation. Let's just grab the original sentence. The original sentence was, let's go to learn JSON. Interactive. We're looking for this one, eval. This is the one. Okay, and let's just share the. Let me just quickly share the link to the project. So let's see where is the getting started. Let's go. Nice, guys. Okay, So that was the first part. Now I want to understand why in the world do we have these two shards. Let me just reopen Versec. Why do we have under our job first run, creatively named first run? Why do we have these two shards? And if we were to go and re-trigger the training in Versec CLI training, picking the right config here, let's see how this whole loading of the checkpoint will work. I'm gonna stop the translation. Let's go to train. Let's see the checkpoint where they mentioned, oh, a lot. Load checkpoint. Okay, only here. So this is the main function of the training. I want to see how the whole loading works. So this would also be valuable if we want to, for some reason, restart the training. So let's kick it off. Running this one. Let's go. I love the translation, guys. The structure is definitely there. There are some errors, but okay. Checkpoint. Model checkpoints first run. Restore file checkpoint last. Continue once. Fine tune for model none. Reset. Save interval. Shard count 1. Model parallel size 1. Checkpoint shard count definitely set to 1. Okay, let's see how it's going to be loaded on both of these. Okay, so do we want to reset the optimizer? No. Reset, no. Optimizer roads, no. Reset meters, no. Reset the data loader, don't. Let's continue. Suffix is shard 0. Checkpoint suffix shard 0. Let's go. Checkpoint path. Okay, so indeed they also grab the checkpoint shard 0. This is the same one that I basically manually have set in our interactive script. If first launch, then we do this. Otherwise, nope, we don't go there. And we go to the load checkpoint. After we load the checkpoint, we'll also reconstruct the iterator. And we'll also reconstruct the epoch. Okay, let's see. I think the epoch where we were was around 8 or 9 or 10. Let me see We can probably quickly see this in here as well. Thanks God for the weights and biases. They're getting free advertisement from me here. Let's go and find, where does one measure epochs? Here it is. We were at epoch 8.896, approaching 9. Let's enter here. Hit F5, enter. Is distributed? Yes, it is. Preparing to load the checkpoint. If any of these is set, then load on all ranks is set. Which means this is going to be set to true. I think this was false when we were running the interactive script, load on all ranks. So now that means we're going to enter here, and then we pass in the file name, but we set load on all ranks to true. This is false. Replication count is 1. Let me quickly reopen the interactive script just to check one detail. So load model ensemble. That was the one we were using here. Then here. Then we were going through file names. And then we were doing this. Load checkpoint to CPU. Let me reopen where we are currently. Load checkpoint to CPU from checkpoint utils. And here we're doing load checkpoint to CPU. We are in checkpoint utils already, so that's the same thing. We're calling the same thing, except that load on all ranks is set to false. Whereas here we set load on all ranks to true. That's the only difference. So will that mess up anything, or will that just... I think that's just going to basically load the same thing on multiple ranks, but nothing will change ultimately. And for generation purposes, we don't need to load it on all ranks. We can just load it on rank 0. Okay, let's quickly enter here. Let's see what's the difference when load on all ranks is selected. Well, it doesn't seem anything is really different. Only here. Only a barrier. If doing single GPU training, or if the checkpoint is only being loaded by at most one process on each node, this should be set to false. Okay. Let's go. Replication count is 1. Get the paths to load. That's the 1. We'll load from the path. And now the second one is triggered. All of this is again set to false. Let's go to suffix. This is shard 1. Shard 1. Load on all ranks. True. Hit F5 to enter here. So here we load like this. Load the path. Replication count. Get the path to load. Okay, shard 1. And we also load, let me just see what happens here, because torch load, shouldn't this be like almost empty if nothing else? Because this, yeah, criterion none. We saw that that one is only a couple of kilobytes as opposed to the main one. Not sure. Model is empty, guys. State model. Model is completely empty here, so we don't care. Model is empty. Upgrade the state dictionary. Let's see, this one is, this is the empty one. If we were to go and switch to the second one, to this one, the state for it is not empty, so it has the model. Okay. Let's continue. Upgrade, what is the upgrade gonna do? If this is not inside, or if this is not, or if this, or if this, we're just skipping over a ton of things. I think this might matter for the next process because it has empty a lot of those details. So let's see. Hit F5, exit. Okay, let's now switch to the second process. Let's enter here. Actually we're not entering because the keys exist, but even though, interesting. It's still gonna be empty model. So when does that one load the model? So we are here in the load checkpoint in the trainer. Last optimizer state. If it's -1, then we grab the master path is this one. Okay, you see what we are doing here. So we are grabbing we're just advancing here. Fairly complex logic for the checkpointing. State model, load into the model, strict true. Let's switch to this one. Let's switch to the previous one, to this one. Here is the last optimizer state. And where does one use that one to fill it in? Last optimizer state. Okay, so this one is going to reconstruct the optimizer state for this second process. Let's see. Let's continue iterating. We need to understand this in a bit more detail just so that we know there are no hidden errors lurking around. Okay. Load from the model, and the model is empty. Broadcast. It's gonna broadcast the state dictionary. So this is the one that has the state dictionary. So on the load state dictionary, what happens is the main process basically broadcasts the weights. So it grabs process group and calls broadcast. Let me see where the other one is. There is no other one. The other one is running as well. They are now synchronized. So we run broadcast. And now we call load. Okay. And then we delete the model. So as you can see, they were synchronized there. So this line forced both of the GPUs to grab those weights and share them. Okay. Then we delete the model from the state. And now both of these will have model. Actually, they won't because we already loaded it here. We loaded it, so we don't need it anymore. Okay. Let's continue. If it's not none, then build the optimizer. Doing some asserts. Load the state from the dictionary for the learning rate. Get the shard. Load the state dictionary. Epoch 9. And set this one to 9. We load the metrics as well. Hit F5. Load it for shard 1, epoch 9. Okay, let's now trigger the second run. This one will probably go through the same process. Exactly. Loads. That's it. Epoch 9. Sets it here. Loads the metrics. Extra state metrics. Train loss. So it loads all of these previous metrics that we were logging during the training before we stopped it. Hit F5. Okay. 78,000 updates. Exactly. That's when I stopped it. That's precisely when I stopped it. And now it's going to load the iterator. We're gonna step over this. Let me just see what this is. We just load this, and then this one is triggered, and then we can go here and go there, load it, and we can continue. That's it. So now if we were to restart this job, it would continue from where we stopped. Okay, cool. So I guess bottom line, from the standpoint of inference, we only care about weights. We don't care about the optimizer. We don't care about the learning weight. We don't care about the state of the training iterator. So I think passing in the shard 0 was a legit move. So we can just say we completed this one. So test the checkpoint on Turkish and Hindi. Okay, now it's time to evaluate using Sacred Blue on Flores. These are the next steps. Let's do this. Test the checkpoint on Turkish and Hindi. We've done that. And then let's now do this, and then we can go to the next one. Okay, how do we evaluate on Sacred Blue? Let's first open up the paper here quickly. SP Blue. A major downside of Blue is that it is tokenization dependent. Efforts such as Sacred Blue have taken strides towards standardization, supporting utilizing community standard tokenizers under the hood. However, these tokenizers do not extend to many languages. Then these guys propose SP Blue, a Blue metric based on a standardized sentence piece model covering 100 more languages, released with Flores 101. In this work, we provide SPM 200 along with Flores 200 to enable measurement of SP Blue. We describe this in greater detail in section 8. We're going to see that it's right now. Okay, and then there is this CHRF++ score, overcomes the limitation of the Blue score. Overcomes this weakness by basing the overlap on character level and complementing blah blah blah. In this work, we primarily evaluate using the settings from Sacred Blue. Okay. And Indic NLP tokenizer for English Latin. Okay. Evaluation on other benchmarks. Okay. Let's see. Table 56. Hindi. Tokenized with Indic NLP. Library. we might need to, so here's an index string. Let's see how this is used. Just to understand, I've never done this. The goal is to build Python-based libraries for common text processing, blah, blah, blah. Indic languages share a lot of similarity in terms of script, chronology, general solution to very commonly required tool sets for Indian language text. Okay. Hindi has all of the support we need. Python 2.7 plus. Oh my god. I hope this is not in Python 2. Text normalization. Multiple representations of nukta-based characters. Multiple representations of two-part dependent vowel signs. Typing inconsistencies. Command line usage. Indic normalize. Input file, output file. Language replace nukta. If I only knew what nukta is. Maybe if somebody on the stream speaks Hindi. Two-letter. Okay. Default true. Default is false. What is nukta, guys? What is nukta in Hindi? Nukta. Hindi, Urdu, Romanized, also known as Bindu. Hindi is a diacritic mark that was introduced in Devanagari and some other Indic scripts to represent sounds not present in the original script. It takes the form of a dot placed below a character. This idea is inspired from the Arabic script. Aha, okay. So that's nukta. So then what's the replace nukta? What does that exactly do? Do you just remove nukta? Multiple representations of nukta. Okay, in API usage, you can import Indic normalized factory, input text. What's the U prefix in Python? Is that like Unicode or U string prefix Python? You're right. Python 3 made them redundant as the default string type is Unicode. Okay, fair enough. So this further suggests that this package might be using Python 2.7. Factory, get normalizer, hi, remove nuktas, normalize the input text. Aha, get the normalizer for guys, this is not hi, this is Hindi. It's a two-letter. So get the normalizer for Hindi and then specify remove nuktas false, and then we normalize the text. Okay. Transliterate from one index script to another. This will, by the way, this will translate, this learning will translate to other languages, because a lot of languages do have to have these types of normalizers. So I want to just understand what's the concept. Why do we even need this? Transliterate from one index script to another. This is a simple script which exploits the fact that Unicode points of various index scripts are at corresponding offsets from the base. So we can also transliterate. A trivial tokenizer which tokenizes on the punctuation boundaries. This also includes punctuation for the Indian language scripts. Returns a list of tokens. Morphological analysis. Okay. String and then analyze. Author. Last revision was in 2014. Not the most active project, one could say. Text normalization. Let me just read this again. Okay, and where is the code? So do I have to download the actual code like this? Aha, there is a GitHub. No, cancel. Is there any GitHub mentioned here? Any link? Okay, view on GitHub, exactly. I didn't see this one. 3 years ago, 9 years ago. Okay, Python 3. Okay, there were some changes in 2019. Ported to Python 3. Nice. MIT license. Okay. Let's go back. We were analyzing Sacra Blue, and we just kind of diverged and went to analyze Indic NLP a bit. Okay, results on Flores 200. That's what I care about. So this is page 102. Let's see what they report. Ideally, I'd report the same metric. We present results comparing the performance against existing state-of-the-art models. We dive into performance on Flores 200 languages, English-centric, non-English-centric, and zero-shot. We primarily show with the This metric I don't know how to pronounce, but also list SP Blue for convenience. Okay, so then let me just add this as a note. Okay, that's what we're trying to do. We primarily show results, but also list SP Blue. Okay. As used for Flores 101. With the 101 language sentence piece tokenizer officially provided. In table 13, we observe that it outperforms the nearest state-of-the-art by almost 7.3 SP Blue on average. That's in table 30 here. Okay. Let's see. So that means we'll have to open up this Flores 101 repo and see what they do, what they propose. Comparison on Flores 101 dev test. We evaluate over full Flores 101. 10,000 directions. We report both SP Blue and this CHRF++. Whoever thought this is a good name, please seek help. All SP Blue numbers are computed with Flores 101 SPM tokenizer. Scores for Delta LM are taken from Flores 101 leaderboard. M2M and DeepNet average is only over 87 that overlap with 101. We also show on that subset outperforms blah blah blah. Okay. So I don't know what Delta LM is. There's a couple of baselines. So this Delta LM is a baseline app apparently that supports all 101 languages. So they support what? What's the difference between these two metrics, guys? Okay, so this is SP Blue. And this is this weird CHR metric. Curve. We can call it curve plus plus. Curve plus plus. Or curve. Maybe curve sounds better. I don't know. 41.2, 23.7. Okay, we can calculate both metrics ourselves as well. Nice. Average. I'd love to find. Is there any breakdown of across, probably in the appendix? We're gonna find in the appendix whether they have reported for the two directions that we support, which is English Turkish and English Hindi. This is performance on Indian languages. We can skip this for now. Performance on Flores 200. Okay, they present the performance on the full Flores 200 dev test as well. We categorize the results into high, low, and very low, and then we further subdivide each of these into out of and into English and non-English centric. Okay. Let's see it here. We went the full circle, guys. We went all the way from downloading the data and then filtering and then preparing and then training to now trying to evaluate. So once we have that whole flywheel going, it's going to be very fun to iterate. We're almost there. So let's see. High, low, very low for English let to X. Okay, and then the average, and then supervised and zero shot. Two different metrics. What do they mean by all? Aha, okay, got it. Without categorizing them. . Got it. What do they mean by supervised here? And zero shot. All SP Blue scores are computed with our newly trained SPM token energy section 811. Okay, just a second. Let me just not forget that. Newly trained SPM tokenizer in section 811.11 for SP Blue scores. Okay. Let's see. Let's just read this and then we're gonna go and see what that one is. Out of these, our training set contains parallel data for 2000 directions. These were never seen by the model. Aha, so that's what I mean by zero shot and supervised. Okay. We present results in table 3. Okay, got in table 33. I don't know how to read. Okay, so this is for these 38,000 directions that they don't have any supervision for. And this is for the supervised ones. There is some transfer, there is some degradation to be expected. Okay. Yeah, let me see what you're referring to. XXYY. XXYY. Yes, it's different because here they further split, right? They further split the XXYY into those that were supervised and those that were not. And here they have all. Yeah. We first discussed performance on English-centric directions. We observed that on average, 2 English perform much better. Okay. We further break down. A language is defined as very low resource if it has fewer than 100,000 samples across all pairings with any other language. That's very low. A direction is defined as low if any one language in the pair is low resource. Okay. We further break down the English-centric into Flores 101 languages and new languages added in Flores 200. On Flores 101, NLLB 200 achieves 50.7. On English outside of English, going outside of English, and 60.9 going into English. Okay. Non-English centric and zero shot performance. Okay. The model has reasonable zero-shot translation performance, likely due to its massive multilingual nature. We added non-English centric mind by text data to our training set, which also contributes to improving zero-shot. Further, we carefully chose the mind by text directions. Okay. We can ignore this. We can ignore the human eval. Toxicity. And then auto domain. We don't care about that for now. For now, we just want to focus on Flores 200. Okay. Having said that, now we have everything we need. Let's go to Flores 101. This should be it, I think. One of these two. Okay. Quick thing we have to do first here is go to Parsec and see whether they mention this weird metric anywhere. Okay, calculate metrics. They do have the evaluation. Let's see in the stopes what happens. Let's go to stopes. Stopes, here it is. CHRF. Sacre Blue. They also have some things going on in here. Computes various quality metrics for the German English. Okay, we're gonna go through all of this now. Let's just do a quick break. 3-minute quick break just to stretch the legs, grab some liquids, and then we can continue with eval. So quickly, 3-minute break, stretching, continuing eval after it. Okay, guys. Let's just stretch the legs a bit and continue in 3 minutes. Cheers. Back. Let's go. Let's go, guys. Let's do this. Let me remove this message here. And let's see. So let's skim through these Jupyter notebooks just to see what they are doing and what we can reuse from here versus Inference versus finding some new code bases that deal only with Flores 101. I'm not sure how Meta decided to split this work. Okay, just a second here so I can see the live chat. Okay. This notebook computes various quality metrics for the German-English translation dataset, annotated with error types. Okay, before running it, make sure that you have installed the requirements and downloaded the translation model and the Laser2 sentence encoder. The results are stored there and later analyzed in the notebook detection analysis. Okay. So there is the model, there is some data for German to English, laser. Let me just see where they're importing the metrics from. Compute ALTI metrics. What are the ALTI metrics? ALTI. I've seen that name oscillate. I've seen that name like being mentioned. I'm not completely sure what it is. Gonna find out, I guess, very soon. Okay, and then, okay, I see here first mention from Secra Blue import CHRF. I do assume that's the plus weirdly named metric from the paper. Okay, so let's continue. Spearman coefficient metric probably or something. Any mistake, they read the data. That's the ground truth. Compute the most severe error for each translation. Okay, let's continue. Compute the metrics. From pre-trained, they'll load some checkpoint. Computed ALTI. Compute ALTI NLLB. What is this? What is ALTI? And where is this called? They import it from Stopes eval. Well, let's just quickly see what we can find there. Let me see the README first. Aha. Let's see what they say here. ALTI Plus is a tool for inspecting token contributions in a transformer encoder-decoder model. It might be useful for detecting hallucinated translations or under translations, whatever that means. Our implementation is based on the code from the paper, blah, blah, blah. The code and README for it are located here. To use the ALTI Plus code, they really love adding pluses to their names. You need to install Stopes with the ALTI dependencies. Okay, we clone and then install with ALTI. You will also need fairsec. Okay, let's see what it does. The code configs and toy data for this example is in the minimal example directory. To download the official 600 million checkpoint of the model, run the script download from the minimal example to create directory, blah, blah, point will read the sentence pairs from test input and compute ALTI and ALTI-based metrics, various text level scores into test output TSV, and token level contributions and alignments will be stored in the alignment JSON-L. The file test input contains column source and MT with a few French-English translation pairs with different pathologies. Okay, I don't speak French. I can kind of infer the meaning, but I don't speak the language. To analyze these sentence pairs, run the following command. Okay, so from the input, metrics, test output, alignment, source French to English. The file test output contains multiple columns with various alt-based metrics. Here we show only a few columns. Okay, so what do we see? Top SC mean, source sum, blah blah blah, MT. I guess that's the translation. The MT standing for machine translation. Okay, I have no idea what these SC are. One can see that the metrics may help to detect hallucinations, whereas this one indicates incomplete translations. The SRC sum, okay. The file test output alignments contains individual subword tokens of the source and target sentences. Okay. The row alt plus contribution metrics produced for these tokens and the alignment computed. Individual subword tokens of the source and target. Okay. Alignment, source, tokenized. Okay. Source tokens are the encoder inputs. Target tokens are the inputs to the decoder. Okay. The folder detecting hallucinations contains the code for reproducing the experiments on hallucination detection from the paper. Blah blah. Okay. So that's salty. It's some weird set of metrics that help you detect apparently hallucinations in the translations and some other details. Code from this paper called Towards Opening Black Box of Neural Machine Translations. Neural Machine Translation, Source and Target Interpretations of the Transformer. How many citations this one has? Cited 3 times. From meta again. Decoding step. Source sentence target prefix. The debate on the state of the European Union is closed. Okay. Esta es la figura 2. This is figure 2. So just like some visualization of the attention. In green, it is shown the information coming from the encoder source, and in red, the information from the decoder target prefix. Alti. I wonder whether... Interesting. This might be a fun paper. I'm gonna put it on our reading list, and maybe later we can go and read it. Do we have a reading list yet here? Let's just start adding some paper reading list. Interpretability, altimetric, meta. Okay, let's go. Let me just organize this a bit, guys. Just a moment. We can close down this one for now, or just hide it somewhere. Okay, let's go back to the analysis. Sorry, Aski, I didn't see all of your messages. There is a CHRF and the plus. They're different. Okay, so they apparently both use the F-score statistic for character n-gram matches, and the plus adds word n-grams as well, which correlates more strongly with direct assessment. We use the implementation that is already present in SactorBlue. Nice. Thanks, man. Thanks a lot for the tips. Okay, let's see what else. They mentioned some other paper down below here. This one. Is there any other mention of any other paper? I don't think so. We can read these. I should start accumulating all of the papers and stuff we've been reading. We read a lot. Again, meta folks. Might be worth to understand these a bit better. I'm gonna add this paper as well to our list. So this paper is on hallucinations, also meta. Okay. Okay, so that was the alti part, and then compute alti. Let's go back to here. So again, they compute alti. And then let's look at an example of alti source target contributions. Okay, here is English German. Let me begin by expressing my embarrassment. Lassen Sie mich zunächst meine Verlegenheit zum Ausdruck bringen. So that's a good translation. And then I guess this is just how much let contributes to all of these. I guess let should be lassen Sie mich. So let should be let me, lassen Sie mich. These two should be very like big numbers, and they seem to be. I'm not sure what's there. Okay. And then begin by expressing with to next. Okay. Cool. Okay, then there is the comet. There is a ton of these different, like they are all pushing for their own metrics. I know that Google has this Blue Earth or something. Ah, thanks, SQ. Do you speak German? I forgot whether you're from Germany. Oh yeah, I think you are from Germany, right? Awesome. So I have somebody to call me out on my bullshit if I'm if I'm just pretending to speak the language. Comment. Comment with reference. Yes, nice, yeah. Thanks for the compliment, man. Comment with reference laser. Encode the sentences with laser. Embed. And then similarity between the source and the MT. So the thing with laser is, that's cool. You can actually use laser as a as a way to verify your translation makes sense. Because how laser works is it embeds sentences in different languages. If they're like the same sentence, just translation, they should be roughly in the same point of the embedding space. So that's what they do here with laser. So they use laser, SPM tokenizer, load the laser 2, and then they create the laser encoder, and then they encode. And then they basically just find the similarities. And then there is the LabC. I'm not sure what this is. I think this is kind of the came before laser. And then there are the NLI models. Why are they using NLI? What? NLI scores. And then, okay, there is this weird metric, word order 2. So this is how you specify the plus, I guess. And you probably specify, this is the number of engrams or something. Who knows what they specify with this. And then it's easy to evaluate apparently. So what you do is you go through the rows of your data, and then you grab the row, you grab the reference and the translation, you pass those in. You can have multiple references, you then score them, and you fetch the score. Okay, so that's how this works. I mean, at least on the API level. And finally, save the data. They have the Comet, they have the laser, the LabC. Okay. And then they have some additional stuff here. Let's see. Let me just see one thing. They never mentioned Comet in our paper, right? I don't think Comet was ever mentioned as being used anywhere. I doubt it. Okay, this one is from Google. I know about this one. Not easily extended. That's the thing with Comet. Yeah. Those are just some attempts to create neural metric that's better correlates with the perceived quality of the output, as opposed to just being on the syntactic, on the lexical level analysis, like n-gram analysis. Okay, so LabC, laser. Cool. So what do they do here? They grab all of the metrics here, and they do some region under the curve, area under the curve stuff for LabC, for altimetrics, for laser. Okay. And then Spearman. Okay. Cool. Do they actually use these NLI scores anywhere? Doesn't look like that's the case. NLI scores are just specified here. Aha. Concatenate. Okay, they do concatenate. Also alti. Okay, so this is kind of very, very thorough, multifaceted way in Stopes to to analyze stuff. Demo, alti, toxicity, mining. Interesting. Let's go on. So that was the detection. Then there is the detection analysis. We already know how to call CHRF metric. Let's now just analyze this a bit more, and then we can go back to our code and implement this somewhere. Okay. Reproduce the numbers and images for hallucination detection. Detection data. Is this the file from the previous script? Yes. Detection data is stored here and then analyzed here. Okay, so here we now analyze this data. Detection data. Nice. Okay. Nice, I love these plots. Even though here it's a bit weird. Okay. Recall. Cool. And then there is the mitigation script notebook. Excuse me. By generating multiple hypotheses with various methods and then re-ranking them with various scores. Let's just get some familiarity for what they're doing here. Data. Creating the translations. Thank you, SQ. What's your name, by the way? So I can call you with your name instead of using, if you're comfortable sharing. Baseline translation. Translate. David. Okay. Nice. So I guess thank you, David, from now on. Model directory. So translate and then random sampling, beam search. Okay, various ways of just sampling. And then scoring the hypotheses. Scoring by Lapsy scores. By Comet. By laser, by alti. It would be cool if they save the actual output so we don't have to run this. So I could quickly see the results. Okay. What does this one do? Does the same as this one with fewer generation methods and a larger pool of hypotheses. Okay. And then the final one. Okay, just reproduces stuff from the paper. Cool, cool, cool. Nice. So I guess the first one from Sector Blue, import CHRF, and then later they use it like this, and then you just generate the translation. So we can easily import that into our code base somewhere. Let me now quickly switch to Fairseq and see where they use CHRF here. We probably don't have to implement anything. Okay. Get reference file name, get hypothesis file name. Okay, so we can basically, as I can see here, we can pass in some files with our generations and the reference, and it's gonna, depending on the metric, choose the command. And then basically it's gonna run Sacra Blue with that metric, and then okay, so that's the generate result here. Get directions. I guess most of these are just going to be a ton of languages. Yes. Aggregate main corpus. Cool. The main just calls this and then generate results in parallel and then aggregates. Cool, cool, cool. This is probably going to be everything we need, guys. This is going to work probably out of the box. Maybe we need to install Sacra Blue if we didn't already. Sacra Blue. Let me quickly check. Activate NLLB. List and see where we have that already installed. We do have, so we are good. Let me just see the version. Python Sacra, whoops, Python Sacra Blue package. Okay, this is a very old version. There is a new one, 231, that was released in 2022. From which code base? Are they submitting the new packages regularly? 230. Is that the last one here? 231. How come they have, how come pip has newer one than the releases? That's interesting. Okay. We have it installed either way, so we don't have to think about that. Let me see what this generate multi does. Modeling, evaluation. What's the difference between this file and the previous ones? Get type. Generate. Aha. This probably generates and then evaluates. Yes. And does multiple blue and this one, and then gets the full command and then runs that. But it first calls the generate script. Okay. We probably don't want that. We can just, let me see what it uses again. Quickly going to run. Set some values there. Creates a final command. Okay. Best output. This looks fairly similar to what we are using for the interactive script ourselves. I don't see any significant difference. Beam. Sacred blue. Okay. Okay. Floor is split. This one. And this one are being called. And then the full command is generate post-process, and then grab those files and pass them to blue and this and sacred blue. What's the difference between this one and the ones above here? Aha, this is just blue, and this is the sacred blue. Okay, so this is split blue, blue, and these three metrics. Okay, makes sense. Let's see what happens in this file, just to understand what we have at disposal before we dig into this. Main, some language pairs. These are some of the datasets, ablation datasets only. Tabulate non-flores. Okay. Blue results. Sacred blue. Okay, similar. And then here is the actual implementation, apparently. Okay. Import sacred blue. Corpus. Okay, just a wrapper around the package that does some things. Okay. Let's run this. Let's see. Is there any README here? Let's quickly see what they say here. We are releasing all of the translations on the following benchmarks. Okay. And then translations of non-Flores benchmarks we evaluated our model on in the paper. Okay. Okay, they can be downloaded here. And then for Flores 200, see here. Preparing the references. Okay. For the other benchmarks, to prepare the reference, you will need to first manually download some of the corpora and agree. Ashimoto, Madar, okay, all of these. But the download other corpora would allow you to reproduce our exact evaluation benchmark. Nice. Super cool, guys. Let's start with Flores and then we can expand And we can expand to supporting the non-Flores benchmarks as well. You'll also need some of the Moses scripts. Okay. Do we have this already? Clone. Let me just see what this one does. Moses decoder. The machine translation system. Look at this README. Glorious. Statistical machine translation system. Moses. It's actually a good name. Biblical name. Getting started, tutorials, training, overview. Okay. Scoring the translations. So we pass in the calculate metrics. So this is the one we saw before. Translate direction, generations, reference direction, references. Then we choose the metric and the output directory. Okay. Besides Flores 200, there are the evaluation benchmarks these are the evaluation benchmarks we evaluate NLLB 200 on. Okay. Okay. Cool. So this is how we call it. We might need to install Moses. And that's it. We already have Flores. Okay. Copy this. Go to launch.json. Create a new eval config. Let's call it calculate metrics. And then set corpus and metrics, I guess. We need to pass in, oops. These ones. So we first have corpus. Let's see whether they require a path or whatnot, but for now, let's just put in something so we can run the script. Translate direction. Again, let's see whether they're requiring a path towards the file or whatnot. I can just put here for now English, Latin, or whatnot. And then reference direction. that can be Hindi Deva, like this. Finally, the metric. Again, have no idea what's the format. I'm gonna say like this. Output directory. And let's put some output like temporary txt, whatever. Okay, with that, let's go back to the calculate metrics script. Let's go down here. Let's set the calculate metrics config. Let's run this. Okay, no module named. Okay, that's because you're trying to, again, absolute import here doesn't work because we're running directly. Import tokenize from tokenizers. So here, maybe we can do something like this. Let's try. Same here. Or we can just add, I mean, this is under what? NLLB evaluation. This is under modeling. Okay, let's just do it like this. And guys, let me know if you have a better solution. But I'm gonna quickly hack this into this. I'm gonna put import this, and then I'm gonna say this path append, and then just pass in the root directory here. Per sec. This should now fix it. Exactly. If you have any better solution for how we can get this to work, like adding a Python path or something in the VS Code, but yeah, for now it just works. I don't want to waste time on those things. Okay, let's go. Let's go. Corpus, translate, pivot, metric, output directory, quiet, average, zero shot, supervised, parse. If corpus mother, then pivot is Arab. If split dev stat, okay, if Flores is in the corpus, which it is, then the split is gonna be dev test. If corpus is this, it's not. Let's enter. So far so good. Get directions. Okay, so here we're gonna see now what exactly are we doing here. Flores 101, Flores African, Indic, Flores 200, (200-206), Mafand, Madar, Tico. Okay, so they basically just end up grabbing the languages, and then we go through the languages and we create English to that language, and we also create that language to English. Okay. So we'll need to modify this apparently. And we'll now have unknown corpus. We'll hit this error here. Let me think. We can create a simple script that does exactly what we need without having to conform to any particular set of benchmarks like this. Or we can just edit this to support custom logic. That's also an option. That's also an option. Let me quickly see. Yeah, it's either this or generate or we create a new one. I don't like this one. Maybe we can try even generate multi. We'll see. For now, let's just analyze this script. And so let's pass in something like maybe Flores 101. Stop this. Put this corpus. Rerun. Oh no. No, wait. I made an error. I thought it's going to stop here, but it did not. Flores 101. Languages. Aha, so it returns here, as you can see. Okay. Rerun. Okay. Combinations. Reversed. Combined. And then in parallel on 32 jobs, they call the generate results with all of the directions of which there is 10,000. So we go through those directions and we go and call delayed with the arguments, processing them 32 at a time. Wait, what is this parallel? I keep on seeing it everywhere. Is that? Okay, that's job lib. Fair enough. Let's go here. Let's put this is an output directory. Let's just create something like, let me quickly put this to like 16, which is more suitable to my machine. Let me also, output directory should be just temporary, or let's make a full path, because otherwise it might create something in the who knows where. Let me see, import os get current working directory. Again, it's gonna create this in the root otherwise. So I'm going to instead go to calculate metrics, copy the path, go here and just provide this like this. Stop this, stop the run, and re-trigger. Let's go. Okay, here we are. Generate results. F5. Let's wait until we hit the first one. Let's go. It's spawning the 16 jobs. We're waiting for the first one to hit the generate result. Why is this not running? Am I missing something? I don't think I am. So there is a get directions. Okay, here we are. So let's generate the temporary one. Okay, and then grab direction. Get the reference file name. What does this one do? Corpus. So the reference one is going to be, okay, got it. So it picks up the reference file from Flores 200 and then takes the reference directory. So this is reference directory. So that's the thing. So got it. I understand how this works now. And then hypothesis is like this. And then input to that file. And then because we picked the metric should be, okay, I misspelled it, but it would be here. And then it would just call the command secret blue reference hypotheses, and then basically pipe that out to the output directory for that metric and run the command. And if not quiet, then we'd be reading the standard output of that process. Okay, all makes sense. Now we can somehow hack this for our own purposes, or we can just create a new simple file. I think for my purposes for now, I'm gonna just run secret blue directly. Yeah. I'm gonna probably use the Stopes implementation. The thing we saw in the detection notebook there. I started stuttering. Okay, detection. So let's try and do something like this. Stop this. Just stop. And let's just create a custom calculate metrics. Come on, Copilot. I'm trying to trigger Copilot to help me, but it's not helping. Okay. I always forget this. I always forget this boilerplate. Okay. So what do we do here? We do the same thing as what they do. We grab this and we do this. As simple as that. Okay. That means we need a reference and we need, okay, so by doing this we can just focus on any particular file. Let's link the, okay, the ref path is going to be under Flores, English, Hindi. Here it is. Copy this path. And then the second one is going to be the empty path, let's say. But that one is going to be where we still haven't generated that one. and then I'm gonna think what's the best way to format the script. So I literally just want to, for these two directions, quickly write some evaluation. So for that, we'll have to go to the interactive script. Now, the thing with interactive is we might have to use this multi-generate, because interactive doesn't have any, it just prints stuff. We can always hack it and pipe this to some file, this print. But it's not meant to be used like that. And there is also all of this additional mumbo jumbo. Okay, so print. So we can either modify this or just use the one that was meant to be used for this, which was the generate multi, this one. This is the script that generates the data. Let's give it a chance, guys. That's what I say. Let's give this one a chance. We just need to see how to set it up. It's also under evaluation. Whereas this one was under evaluation, but under evaluation directly. NLLB evaluation, and this one is under modeling evaluation. Okay. I think I've run before this generate multi. Let me see. Do I have multi anywhere mentioned? Generate. There is this one. I might have used checkpoint task. Okay. This might be the one, guys. This is all we need, just to modify this one a bit. And then we can go open the generate multi, config. Aha. This one actually has the multi specified here directly. What's the difference between that one and this one? Okay. Modifies. Okay. So I guess the generate config I have is probably for the fair-sex CLI generate here. This one is probably the one I use it for. Yes. Okay. So let's go back to generate multi. And let's specify the right arguments here. Make sure it makes sense. Language config. We're gonna create our own. (221) through 16. That's 206 languages. So these are the ones we actually use. Sample is to be used only for testing mode. Flores ablation, Flores full, WMT, T-code, TED, LaFond. So those are all of the other ones. Okay, let's just copy one of these. And let's call it custom. Full has all of the directions and all of the languages. Again, that should be 814, 613. That's the 202 languages, right? Yes. So let's start from this one. Let's take the full, let's just copy it, and let's call it custom. And then we only care about English Latin to Turkish Latin. We only care about this one. Well, I can kind of delete everything while I'm at it. Delete this, and then English Latin, Hindi Deva. We can leave all of the model languages, that's cool. I'm not sure what this is used for. And I'm also not sure we have to pass them the bin root where we have our data but binarized, which we've done before, but that's in Stopes somewhere here. Let's go to prepare data, and then prepare data new, and then under data bin char 0, I think that's where we have the validation scripts. Yes, and we care about Hindi Deva and the other one. Okay. So yeah, we kind of have to copy this path somehow, I guess. Let me put it here, and then we're gonna check out how that one is used exactly. Okay, so with this, we have the custom YAML here specified under language config for the cluster. We're gonna go with null here, which means running locally. Flores path, non-Flores path. Let's just leave whatever those are for now. We're gonna check how they're used. That's the cluster. There is the launcher. There is the model config. For that one, we can use the full 203. That's exactly what we need. We need the full one. So let's go here. So we want the full one for model. We want to custom one for language. We want to generate multi as the base. That's fine. Parsec root did not change. Model folder did not change. Eval on all. All of this is good. All of this is good. We have to see the definitions here. Checkpoints, checkpoint. I'm gonna see how this one is used, I'm not sure. Language pairs per job, 10 jobs, that's fine. 10 directions. Valid. Source, dense, add true. Okay, let's open up this one side by side. And we are almost configured to run them. Okay. Let's see. Example. Cluster remains example. Okay. Open up the giant multi. We overrided these ones. Launcher. They've set launcher to submitted. I actually want launcher to be local. I want the launcher to be local. I'm not sure what I have to set for lang. I guess we'll see soon enough. I should have not modified this one. I should have created yet another one, but okay, it doesn't matter. I'm not going to submit it. Okay, what else? We specified this model type dense, direction, all checkpoints, checkpoint best. I think for, let me see, for model checkpoints, we want to go to, let me collapse this, collapse this, collapse this. First run. I think we need to additionally type in first run here. Exactly. And then underneath the first run, we want the best. Okay, we want the checkpoint best. So that means don't override this. Okay, split validation data. Aha, so this is how it's specified, as you can see here. So cluster data directory is the first one. So cluster data directory is the first one. For that we need to specify, go to Stopes. I guess this is the copy the path, data directory. Okay, let's go back to here. So once we have that, then it grabs the lang config binary root. So then we go to lang config, which for us was the custom one, and it will grab this one, and then data bin, and then shard. So I think we can leave this one just empty, right? If we leave it empty, then we end up with the one the direction I just pasted, and then underneath it we just have to append data bin shard 0, which it does here, data bin shard 0. Okay, looking good. So either or even better, maybe just to be a bit cleaner here, go and grab this. Prepare data is the root, and then just grab this one. Okay, that's an additional solution. Okay, maybe that's a bit cleaner. Let's go back to here. That's now good. SPM model is also under data directory, and then this, and then vocab bin, and then this. Or we can just override it. Why do I even care? SPM model is going to be under fairsec. Here it is. Copy the path. That's it. Encoder length token, this is good. Output directory is the model folder, which is specified as this. Beam size, let's set the beam size to 5. FP16 can just remain true. Replication count needs to be set to, okay, replication count needs to be set to 1. Fine tune, nothing there. Add data source true. Data label, okay. Looking better, guys, looking better. I think we can kick this off now. Let's go to the generate script, generate multi, and let's run it. Metrics only. Let me think for a second. Metrics only. Set to false. Don't do the metrics only. Instead do the, okay, got it. We are doing both generation and metrics. So if we go here, it's false. We're gonna enter and we're gonna configure the launcher. This one, and then, okay, so that's how it looks like. Let's run this, guys. Set. Actually, we set no args, and we run this because we set up everything through Hydra. Okay, it says, aha. Okay. I messed up with the launcher here. I'm not sure exactly what order do they require from me, but let's see. Let's rerun and see what exactly it's complaining about. So it's complaining about multiple values for launcher. To override a value, use override launcher. Local, aha. Oh, yeah, okay. That makes sense. Rerun. And let's go. Nice. Works. We configure the launcher. Again, let me just make sure this launcher makes sense. I'm not sure about the lang. What's the lang? No idea. Why do I need to specify a lang for a launcher? How does that even make sense? It didn't fail, so we're good. Let's enter here. Pass in the config. Make sure this is a directory. Make sure you can read from it. And then launch. And the launch does what? We can collapse tabulate for the time being. We can collapse this and this and just go to the actual launch here. Requirements. Two GPUs per node, 8 CPUs per task, 48. I think this is what I've set. Okay, this is fair. array. I'm gonna put a breakpoint there as well. And let's go step by step and understand whether we passed in reasonable values. If all, okay, then we grab the language config all. Exactly. And that's only 2 directions. So far, so good. Then we go through the directions. Again, if this is all, or, then we go to filter pairs, append. And then again, so we just go with everything. And then we chunk them. But because we only have 2, we just end up with everything. And then we return the job config, validation, checkpoints, and language pair chunks. We iterate through those. There is a single one, there is a single one, there is 2, so that we're going to create 2 jobs. 2 jobs for the validation, this checkpoint and this pair with data label. I'm not sure what data label is, but it doesn't matter. I'm gonna find out soon. Cannot pickle coroutine object. Oh, I've seen this one before, and I didn't manage to solve it, I think, or I did find some solution in some of the issues. Let's see. Why are you complaining about cannot pickle a coroutine object? Where from here? Utils. This is just in the submitted. This is the wraparound slurm. Okay, let me think. Requirements. So what happens after who calls array? Probably submitted calls array. And then it complains for some reason. I just want to hit the run. That's all I want. Am I asking for too much? I think okay, we can step through and see what's going on. Because we're not hitting the run. So somewhere somebody called array. Okay, let's go like this. Let's just see who calls array, and then we can step out and continue from there. Okay, somebody called array. Who called array? Schedule called array. Schedule is a function from launcher py, from submitted, from Stopes actually. Okay. So you grab the array. Let's put the breakpoint here. Hit F5, we're here. We have 2 job arrays. Awesome. If it's not none, which it's not, then we say grab the length and say progress start, and then we call schedule with the module and with the value array. The module being the generate multi module. Fair enough, and then there is this. Okay, so let's enter into schedule array. We get the executor for the module, which is probably going to get requirements. Exactly, so the module name, the module requirements. Update the parameters using the name and the partition. If the partition is slurm, which it's not, otherwise grab the comment. If it's not none, we update this. and we return back the executor. Okay. Now going through the value array, we pass in a task. Try and get the cache. Missing cache. And we can just go there, okay. Quickly, let me see. Why do we have only a single? This should be an array of 2. Where did the second one disappear? I had a value array. Where did the second one disappear? Probably cached. Okay, for some reason the second one is cached. We're gonna see what happened there. So now we go here, and for the task, we call the module, and then go here, waiting. Just a single job. Submitted the job. Track. Oh, wait. Okay, so somewhere here, something happens. Someone is complaining here. Executor logs. Pickle saved temporary. Why are you complaining? Object, coroutine object. So what was passed in the dump? This, what was passed here? Raise error. Run a job. Process the job inside of the folder. Let's go quickly to the outputs. Let's find this particular location. Let's just change there. Okay. Error. Could not dump, cannot pickle because of a temp already exists. Loading the pickle. Okay. Save temporary. Submitted pickle. So this is the job pickle. We can maybe quickly load it and just see what's inside here. Copy the path. Let's just do it like this. Copy this one. Let's go here. Create a temporary Python file. Path. And then the file name was what? This one. And then open. Okay. Let's go. Okay, maybe Copilot knows a bit more than I do here. Oh my God. Oh my God. Okay, it's now repeating itself. Let's go here. It's useful to get a bit familiarity with submitted as well. Debugging this is going to be useful. Let's rerun the job. Load the pickle. Hope it does not fail. And now, can we actually see stuff here? Not defined. What? I might be in a wrong. Okay, we're here. We're here. Delayed. Delayed submission object. Let's just do like a dir class, blah, 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 length. Let's just do string of that whole thing just to see everything. And indeed, there are arguments, done, dump, function. Maybe not all of these will be here, and maybe this fails already. I think this needs to be function. Yeah, failed. Okay. Function, it was perfectly certain, but yet perfectly unreliable. Sounds like a language model. Okay, let's run. Again, going back here. Whoops, I'm again in a wrong process. Let me go here. Let's go here. Args. Okay. Well, why not just, why am I doing all of this? This is gonna also fail. Args. It doesn't have args. Okay, keyword args, it does have those. Cache object. Iteration value is the job config we've submitted. Looking good. Executor. Does it have executor? I doubt it. Yep, it failed again. Okay, it's just bullshitting me. So instead of doing this, let me just rerun. Yes, rerun. Again, go here. And now I'm going to just analyze it like this. So go delayed. Go to args, nothing. Go to done. Delayed submission done. Bound method. Just keeps on. Okay, done. Function. keyword arguments, load result, set timeout. Okay, so it just keeps on sending me these delayed submission objects, result and stuff. Class delayed submission. I can't find it because this is actually in. Okay, let's stop this. Let's go back here. So this is where we failed, because this object folder, this one, job environment, wait time 60. So if the submitted file does not exist, which it does, it waits. If it doesn't exist, then we raise error. Otherwise, we go and create, we'll load this job. So here is that function under submitted. Pickle load. This is the same thing we've done. Yes. Go back. So loads the pickle. And then asserts some stuff and then returns the pickle. So that's all it does. And then handle the signals, whatever that means. If there are any special signals, okay. Grabs the result. But that's, I guess, where it fails. So let's put a breakpoint here. Let's stop this. Again, let's stop this. Let's go to generate multi. Let's rerun. Hit F5. Hit F5 again. Hit F5 again here. Here we are. Result. Job completed successfully. And then tries to do what? Grabs the result pickle. Interesting. Which it does not exist. Wait. So basically what happens here is that this D5 blah 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 D5, this one exists here, okay, and then tries to open up so creates a temporary here and then attempts to dump this one and says completed. What? So this is where it will fail. It will attempt to save this coroutine object, and then here it will just hit the exception and say could not dump because of dump error. A temporary saved file already exists. Raise an error. Weird. Cannot pick a coroutine object. Why are we hitting this one, guys? What's the thing here? I just want to run the generate multi. Why is this so hard? You need to remove a sync before the inference. Do we have a sync anywhere in our generate multi? A sync IO, await, we just call schedule. Generate multi. Why is this one so special? Like this is the only one that's not working. Maybe because of requirements. Maybe I need to, if we set this to 0, similarly to what we've done for some of the other ones like Stopes, if we go to filter, modules, pipeline, filtering, if we go here, requirements or prepare data, requirements, GPUs per node 0. That's right, maybe GPUs is somewhat confusing this. I have no idea, but it's a bet. So from this to this, let's rerun. Maybe the requirements are confusing it. Is there any other difference? Let me see. Test per node 1, GPUs 0, CPUs per tasks, memory. This one is also different. Okay, we're gonna try a couple of options here just to see whether stuff works or not. Rerun and see what happens. Let's not put this here anymore. Version the temporary saved file already exists. Let's do one thing. Let's go to Stopes. Actually NLLB. Let's just go to versec issues, see whether anybody else complained about something similar. Close. Guys, if you find a solution for this pickle thingy, let me try and just search pickle. That would be amazing. Pickle. Submitted. OM. Can't pickle. Maybe it's similar. Can't be pickled. Can be pickled. Can't, or maybe cannot. Cannot handle. Cannot. Okay. Aha. We might need to wrap up into omega config. Let's see. Okay. Let's see whether this is somewhat useful to us. Where in the generate omega config, there is the dict config. Where is it used? Here, and only there. And what's about for some of the other scripts we are running? If we go to stops, if we go to like here, omega, it's used to save the config. Okay, and what about any of the other ones here? Dict config, line processor, array. Is any of these using array? Array. This one is using array, okay. So what's the difference here? It has a very similar structure. It returns array, yet it works. So what's the difference? Validate data. To launch, we do what? Call validation module. Validation module is basically this validate data. So what's the difference between this one and this one? They both inherit, let me see, I'll have to open it up on my second screen, but bear with me. So both are using stops module, okay. The config here might be different. Let's see the config. for validate data is just some data class. What's the config here? We pass in Hydra. And here we don't pass Hydra, we pass what? We pass a different type of config, which is a data class. So maybe that's the issue. We are passing in a config here, this Hydra, and it might not be pickable, I don't know. And then array returns job configs, which are also, okay. And then requirements and then run. So that's it. Init array requirements run. All the basic components are the same. One works, the other one does not. So config is different and return value is different. Let's see, let's rerun this. I hate these stupid errors. Okay. This is just a regular config. Maybe is dictionary must be pickable, right? Those things must be pickable, like. Maybe some of our variables are unpickable. Let's see, what do we have in here? Just paths, names, dictionaries. Launcher. Well, these are just strings. All of these are just strings. Right? What exactly is causing the issue here? I completely don't understand. The arrays cannot pickle coroutine object. Oh my god, I hate this. If we get too blocked, we can just run the interactive script and we can modify it so that we get the output. But this is ultimately the best solution, like for generation and evaluation. It already has all three metrics we need. We just have to set it to work and then we are golden. But currently struggling to fix this issue. Let me see what other tasks we have after this. It's gonna probably happen after the lunch break. Let me see. Oh, I forgot to check this. and then some in the transcript I have to double check some things we've been logging, and then understand some variables, and then I'm gonna kick off another run tonight. Okay, there is a ton of to-dos for today. A ton of to-dos. Why are you complaining exactly? Object 1. Coroutine object, generate multi-module run. We do that same thing for every other run that we have. Did they mess up something? Maybe in the launcher. Oops, where are we? Maybe there is some version mismatch. Where do we have Stopes? Do we have it installed inside of here or what? Conda activate NLLB. Stopes 110 under NLLB. It's just a submodule. So what's the damn difference? Go here, open up the filter, validate data, prepare data, launcher is local. Let's compare these two. Maybe I have to just copy this to here. Let's just try this. I know this works. It might be messing up with cluster. Cluster local. Launcher. Cluster. Cluster example. We'll set some things. Let's just try and see where this runs. Maybe this changes something. Ah. Hi, Smith. Let's run this. See whether that fixes it. Praying to the gods of cluster is not in the struct. Snap you. Okay, because this one is expecting probably some cluster configs. Is data class pickable? Not sure. Let's just see whether a data class is pickable. But like again, if we take a look at stopes, if we take a look at prepared data, let's open up validate. And just see. Literally 100% better than Google search. I mean, we can quickly test that ourselves as well. So where is that coroutine thingy going on? Is that like a Python concept or? Why is it some, like, wait. This is killing me. I'm gonna just run. I'm gonna run Flores. prepare data. Just change the output to temporary. 2 files there. Prepare data. Let's see. What's the difference? We have this pipeline run. How is this one called here? Async IO run, and then inside of the run, eventually we call schedule await. And here, async IO run, we call the pipeline run there. Here instead we call this. And then the pipeline run, we call this one immediately, which is a sync. Okay, and main here is also sync. So all in all, we call an async function here. Same as in parsec here. Both are async. What's the difference? The difference is, the difference is this one doesn't have any input arguments, whereas the main one has. That might be it, guys. Here we are passing a async function without anything being passed to it, and we just run it directly. And then inside of here, we go to validate, and validate has these await schedules. So we do the same thing here. Like we do exactly the same thing here. We go to a function which is a sync, but instead it has this, and then somewhere inside we called schedule await. Nothing different compared to here. So here we have schedule awaits eventually being called from prepare data. Run is a method there, and here we have independent. Okay. What if we do what if we just comment this out, remove this, and then load config here. No, but Hydra will not. How can we call Hydra like this just to avoid having to run? Wait, no. Let's ignore all this. Let's not do that. Let's not do any of that. Instead, why not just call this thing here? Okay. And then call module run directly. Let me see. Prepare it and then call pipeline run. Just call the run. Now, I'm not sure this is gonna work, but I'm fairly sure this is some sort of a solution. We'll of course now ignore tabulate for now. If we just directly call run, which is also a sync method, the difference is I don't know. Let's just try this. Okay. Well, at least I got it running. Maybe. So this is the issue, guys. It's passing this config object, which is messing stuff up. So in Stopes, we never called, if you take a look, we never call with any arguments here. We just call the run here for prepare data. And then for the filtering, we do what? We call main, blah, blah, blah. And then here, we call filter group. And filter group does what? Goes through the executor and submits to the executor. Okay, this is a completely, there is no launch here, schedule or something. No. Okay, this is different, but like looking at the prepare data, the logic is you create this object, which is the same as what we have, and then directly call its run method. And then in the run method, you might have some of these jobs that you have to schedule. Okay. Let's see. None. Ha ha ha. Okay, okay. So we can run and fetch these jobs and then pass them in here. Let me think. What's the easiest way to do this? We can create it like to be serial. We can, if we did something like this and we just called array, if we called self array, it will give us everything we need. Let language pairs. Why is this not pickable though? This is just, aha. Okay, because it's some class. How can we make a class pickable? Deep copy. Validate. Merge. Okay, guys, I think what if we just wrap this into this omega thingy, this whole config? What if we, let's find that solution. I did find it somewhere. Somebody mentioned this. Okay. Maybe something like this will work. Let's quickly see. Okay. What happens now? Will this fail? It did not fail. What's the type? Omega dictionary. This might just work, guys. This might just work. Ah! Terrible. Well, we can hack around it. It's not gonna be the nicest solution, but why not just convert this into a complete dictionary? Let me see. Why is this not just a plain dictionary? Wait, it's already this. Okay, let me run this, and then what's the type here? Okay, we didn't change anything actually. Let's just convert it into a plain dictionary. If we do pick of config, yeah, let's just pass this as a pure dictionary. Maybe that helps. Well, we'll just have to change some things a bit, maybe. Or let me think. Nah, let's just do it like this. For now. Let's just see whether this makes it work. Okay. Well, let's hack it quickly here just to see whether we get it to work. Okay. If that's how you want to play it. So the only place where I'm calling is here. I have to convert it here, otherwise it will fail in the stops module. So this has to be like this here. And if that happens, then it fails. Okay. Okay. So what do we guys do? I'm gonna create an issue because this is super annoying. Let me just report what we see here. When we run with Hydra, when we run this on with Hydra, we get cannot pickle coroutine average. I'm just gonna paste this and create an issue because I've been hitting it multiple times already. Let's maybe open up the script here quickly. The script is under Versec examples. We'll have to switch to the NLLB branch. Switch to NLLB. Go to examples. NLLB. Modeling. Evaluation. Generate. Multi. There is no code. Expected behavior is this definitely doesn't have to do anything with this environment. Let's just find the installation instructions. Here are the installation instructions. None of this matters. Let me just paste them the I can upload I can zip to the directory here. anyone change this? Let's see one more thing. We go back to fairsec and find the error. The error happens here. Cloud pickle. Process job. And this is already okay. Cloud pickle. This is now a different package. Okay, let's find this particular line and submit it. This might be a, by the way, this might be a submitted issue, not a fairsec issue. Let's see. Pickle. Combining results without leaving the shell running. Temporary save file already exists. Update to 133. Maybe that is the solution. Let's see. Which version do we have? Submitted 145 actually. What's the latest version of submitted? One two oh. One four five. We are at the latest version, at least according to pip. This is a version from July 2022. Wasted so much time on this stupid bug. Huh. Are we using local executor or Slurm executor? Let's see a couple of things. Let's go to our main function, executor. Where do we pick the executor here? We just call schedule jobs. Wait, what's the difference here in scope? Okay. Guys, I don't want to waste any more time on this, to be honest, until somebody replies or helps. This was too much. I'm gonna just do the hack that I found before. So that's this. Run this like this, directly here, and then call module run. Actually, let's first pick up the values here. We're gonna get the job configs here. Let's hit run. Here are the arrays. Why do we get only one? Isn't this supposed to create a multiple? Okay, let me just stop again. This is super annoying. This is a single one, this is a single one. But here we should have two. Oh no, it's actually one. So we chunk them into a single job. Okay. Got it. Okay. 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 So now let's just save this. Okay. Let's delete the changes. Let's go here. The iteration value, we're gonna grab the jobs like this. And then we're gonna go and say for iteration value in jobs. We run this. This should now work. This is equivalent, it's just that it's slow because it's not running in parallel. We just made it a sequential implementation. And I just have to modify here. Again, this needs to be put in here. And then we just need to call the run method instead. Voila. Let's go. Here we are, jobs. We grab the first one. Actually, we might need to pick a single pair, language pair. Let's see. Oh, okay. So we're gonna literally go through just this, and then for language pairs, we grab the source and the target. Okay. If data label, then do what? Output directory, data label, otherwise output directory. Checkpoints. Okay, so the only difference is the name of the output directory. We create this one. Okay. And then if it exists, otherwise we grab the checkpoint. If the model type is dense, we add this. Checkpoint best shard 0, I think that's the right one. Checkpoint best shard 0, exactly. We grab the model first run and we just append this and we get the final model. Well, not quite. Not quite. Instead, we have to have the checkpoint name here, right? Why do you even use, this is a bug again. Here is another bug. This should be here. Model name, like this. Okay. Rerun the whole thing. Get to here. Aha, so it's ultimately just calling. Okay, so it's ultimately just calling the generate script, but it additionally does the this through a for loop, and then it additionally does the evaluation. Okay. So data, here is the data in shard 0, the path to the model, the languages, let me see. Does all of this make sense? Okay, okay. 50 sentences. Results path into there. Okay, let's go. Let's go here. Flores dev if validation, otherwise dev test. Okay. Flores path. Aha, so that's where the Flores path is set up. So we go to cluster, config cluster. Flores path needs to be set to here, I guess. Let's just copy path to this one or this one. Copy the path, go back here, dev. Turkish Latin. Underneath this, okay, actually we want a bit different logic here. We want to set the florist path to directly where we want it for now. So that means going to here and setting florist path to exactly the dev. And then under the dev, we'll have the actual directions. Okay, so it expects this to be directly underneath the file. Okay, whereas I changed the, so we'll have to do something like source target. Exactly, and then underneath it, we'll find the right one. So that's a small modification I had to make there. And then blue, okay. Let's rerun this. Hit run again. Hit run. This should now work. Dev, and then English Turkish, and then Turkish Latin dev. I think that's the right one. English Turkish, and then Flores. Okay, it's actually gonna be a bit different again. So it should be target. The reference file should be Turkish Latin, but we need to put this like this, and then this will be just Flores 202.this. Okay, let's rerun. This is not good. So this is the ref file, and then we pass in the outputs, and here as well, and this, and there is a full command. Generate a command file. We save the file there, and then we run the full command. Let's see whether it works. I completely hate running these processes like this, because there is no transparency what happens here now. I have no idea what's going on. No feedback whatsoever. That's why I love running directly the files. Did it fail? Did it not? Do I have to go and check that? By the way, the camera might die any moment, and I'm gonna wrap up the stream in a minute. Let me just see whether we have anything here. If it dies, we're gonna continue in roughly 30 minutes after the lunch break. Let me just see whether we got anything meaningful here. Okay, I guess it's printing the results here. This is the script we're running. This is the generate, okay. Let's hit run again. There is a second one, Hindi. Blue results. It actually worked, guys. I mean, when I say it worked, I mean it did not fail. Score 33.4. Nice. Nice. Eval output. Okay, we're gonna analyze these after the 37 for Hindi. What was the result for them? If we go to we can maybe try and find a solution here a bit later. What did they got for Hindi Deva? I guess much higher, 50 something, right? Corpus, English, Latin to foreign. Hindi looks to be around 60-ish. Let's see whether there is any. This is toxicity stuff. We don't care about toxicity now. Let's see whether there is any table. Whoops, let's go up. Is there any table here? There is something. F1, precision recall, FPR. That's not it. Is there any report? Nope. Other than this, I don't think. It looks like it's just below. No, actually exactly at 60. Whereas we are around 37.2, which is obviously terrible. But that's like a 50 billion plus parameter model that was actually properly trained, not something that somebody randomly kicked off like I did. So this is gold. These are cool results. We have a temporary hack to just do the evaluation. Not super happy with it, but it works. So having said that, let's wrap up the stream and let's continue after the lunch break. Let's say in 30 minutes. So that means 4:10 p.m. CET, Central European Time, in 30 minutes, guys. Cheers. See you very soon.